Everybody in the construction industry loves to talk about data, that we need more of it, that it's the key to project success, and the future of the construction industry relies on data. And with the rise of artificial intelligence, the hype is only getting louder. Here's a question that I think most people couldn't actually answer. How does data help construction contractors make more money? Or are we just collecting spreadsheets and site diaries that are never actually used? In this video, I want to give you a framework to explain how contractors and construction managers can actually use data to drive better project results. I'll be covering why data matters, why managing data on construction projects is inherently very difficult, why data matters even more now due to the rise of AI, what good construction data practices look like, and a practical guide to managing data on a project. So to begin with, I want to unpack this question of why data matters because I don't think it's immediately obvious. And I think most of the people who talk about how fundamental data is the future of construction haven't properly thought through the question. Because the real question at the end of the day is, how do data and records help contribute to the success of construction projects and construction businesses? I'm not going to go down to the specific level and specific use cases. I'm going to talk more about the general principles behind why data is actually incredibly important to the success or failure of construction projects. There's 6 fundamental reasons why managing construction data is important, but also going to become increasingly important as time goes on. Number 1 is better data means better commercial decisions, better decisions about the contracts you sign, the decisions you make to execute the project, how you spend money, and how you complete the project faster. For example, what it means is you're able to use real numbers and real data, not gut feel. So you can use data for better variations approval. You can substantiate your variations with records of what happened every day on site, when emails were spent, when correspondence happened. You can use better data for better subcontractor or supplier evaluation to look at historically how they've performed. You can use data to better plan your cash flows when you're spending money, map it against your actual payment terms and the payment terms of your subcontractors. Reason number 2 is to monitor and control the performance of your project, to really assess whether your project is being run well, whether it's going to make money or whether it's going to lose money. Fundamentally, monitoring and controlling your project, the principles of earned value management, cost and schedule tracking and reporting, and generating insights comes down to the data and the accuracy of the data you record. You can use your cost data to compare how you're spending money against your budget, whether you're 15% over on formwork, and identify ways to fix it, how you can use it to manage the time or when you forecast to finish the project, looking at weekly site diaries, the quantity of work total from the drawings, the quantity of work you've completed, how long it's taken you to complete this, what resources you've had allocated to these tasks, and also look at data to help you manage safety and quality. You can look at the defects, the type of defects you're getting, when these defects occur, how they're getting closed out, how long they're getting closed out, how many defects you've got left. You can basically, by recording and analyzing this data, you can actually start to paint a picture of how your project is performing, not subjectively how you feel people are managing it, but objectively looking at concrete metrics to assess whether it's a well-performing project or an underperforming project. Instead of just simply using it to monitor and control your projects, data helps you forecast what's likely to happen in the future. Now, this idea is obviously very linked to point number 1, which is better commercial decisions. But data is the basis of how we forecast what's likely to happen in the future, and then we can plan, prepare, or even prevent things like this happening. For example, we can look at, by tracking labor productivity across projects in the time of year, we can show that concrete pour productivity is lower in winter than it is in summer, and we can use this to integrate it into schedules going forward in the future. By logging all of our weather, we can accurately estimate how much downtime we're likely to have on different projects throughout the future. By logging our subcontractors' performance, we can determine whether this subcontractor, the estimates, the schedules they provide us are usually on time or longer than they anticipate, and accurately forecast buffers for doing this. So data can be used to forecast what's likely to happen in the future. Data can also be used to protect you in the present. What I mean by this is good data is essential to protecting yourself commercially, both in disputes you have with your client and disputes you have with your subcontractors. Using data, you can prove what's happened, prove what's been agreed to, and instead of ending up in he said, she said situations, trying to blame another person or argue something, you can always revert back to the facts. But the only way you can do this is if you record what's happening on your project and you have accurate records. Who said what happened on this date, what was agreed to, how long something actually took, how long something's likely to take in the future. You can use it to resolve delays, subcontractor variations. You can use it to substantiate variations you're making to your client, defects, how long these defects are being taken to close out. Basically, the more data you have, the more records of who said what, of correspondence, the better you're going to be able to protect yourself commercially. The next reason data matters is it's the only way we have to learn and improve as a business, as a system, other than as an individual. Most lessons learned on projects stay as lessons learned with the individual. The project manager learns about a certain type of paint and whether it works on a certain type of structure, or that a certain supplier's product isn't well suited to another supplier's product. Generally, those lessons stay embedded in the project manager and he takes them with it. Yes, he can apply them to projects going forward, but the business never captures this data. With data and records, as a business, as a system, we can learn and improve and basically stop repeating the same mistakes every single project. We can use things like estimating feedback loops, where after the job, we use our actual cost data to estimate the cost of the next project. We look at the specific issues we had, where we had drops of productivity, where we had delays, and integrate these into our projects going forward using our lessons learned. And we can always use data to improve the performance of our ability to schedule. So many construction management functions rely on input from experienced individuals. The more data we can collect, the more lessons learned and insights we can capture, the more that the business will be able to prevent the mistakes happening on their future projects. Now, the final reason having good data is essential for a construction business, and this is only going to become bigger and bigger going forward, is as AI is integrated into more tools, the more data we have about our projects and our performance and our specific situations, the better we're going to be able to use these models. Our ability to use these AI models so heavily relies on the context we give them around the problem we're trying to get them to help us solve. The more data we have, the more specific insights we have, we can improve the context, the prompts, and get much better responses from these AI tools. Okay, to summarize, data is useful when it helps us see what's happening now, predict what's likely to happen next, back yourself up when challenged, improve future performance, and to get the most out of AI tools moving forward. The next thing I want to talk about, which I think is important to bring up and address, is why managing data on construction projects is unbelievably difficult, but not just managing it, but getting the most out of it. Unlike manufacturing, construction doesn't occur in a controlled, repeatable environment. Every project is different in distinct and important ways. The contract model might be different. The scope and responsibilities of the client and the contractor and the subcontractors will be slightly different. The location, the ground conditions, existing utilities, the weather, the product and the suppliers will all be different project to project. This variability makes two things incredibly challenging: capturing the correct data consistently, the data that's actually going to help us improve our projects and business, and then using that data later in a meaningful way. I want to use a really specific example from two projects I worked on and then my future involvement in a 10 to 10. So before moving into Construct IQ full time, I used to work on the construction of solar farms and around inverters. So what converts the DC electricity into AC electricity on solar farms, we always put in some sort of in-ground earth grid. I was working as part of the tender team, and someone when I was working with asked me, do you have good numbers on the productivity for installing these earth grids? And I looked at my cost tracking records from two separate projects to try and give a meaningful answer to this question. Project 1 was a solar farm that used power electronics inverters. The earth grid was installed in summer in dry ground conditions, and it was a 120 millimeter squared earth cable with 4 terminations per inverter. Project 2 used SMA inverters. It was winter, it was muddy, and the design used a 70 millimeter squared earth cable and there were also 4 terminations per inverter. On project 1, we didn't have to track and report the individual earth terminations. We just tracked the number of earth grids a crew did per day. It was a rolled up number, including the excavation, laying the cable, terminating the fit off, and the backfill. On project 2, we had a specific format we needed to report productivity to our client. So we tracked the number of individual earth terminations. So when I got asked this question from the estimating team, can you give us some numbers to help estimate future projects going forward? I looked at the 2 sets of data I had, and the numbers, the information, the format of the information was completely different. The tasks at face value seem relatively simple, but everything about them was completely different. I find this is an incredibly common theme when people talk about data on construction projects. Yes, you have data, but it's in a different format, it's captured at a different level of detail, and it reflects different design, site conditions, and other project-specific information. So when it actually comes to being able to and wanting to use this data in the future, it's not just plug and play. You need to understand so much context and information around the data, and it almost becomes useless. So even that incredibly simple example of a task on a project and wanting to use the productivity rates from that task to estimate something going forward becomes an incredibly complex and challenging job. So let's dive into this in a bit more detail. Let's explore what specifically about construction makes these 2 things, collecting the right data and then being able to use it going forward, very challenging. So number 1 is simply that every project is unique. No 2 projects are exactly the same. Even if you're building the same road, the same number of lanes, the same lights, the same everything, they're in different locations. There's different contract types, there's different delivery models, there'll be different weather, there'll be different project teams, there'll be a different design, there'll be a different client, which makes them almost incomparable because so many important contextual things are completely different. Manufacturing, on the other hand, it's the same process repeatedly on the same production line with the same highly controlled inputs. Reason number 2 is that information is scattered. The data, the meaningful data we need on our project is trapped in chats, emails, PDF, field notes, spreadsheets, photos, and the worst one, people's memory. Manufacturing, on the other hand, it uses centralized enterprise reporting processes. They have SCADA systems. It's structured, it's time-stamped, it's categorized, and it's set up to be able to reuse. The next challenge is we get inconsistent data structures between projects. One site might track daily crew hours in a spreadsheet, another might write them down on a whiteboard. More mature industries like e-commerce log every user action and financial traction in the exact same format across platforms. The next challenge is that tacit knowledge or knowledge gained through experience gets lost. There's no good ways to track and manage this data. Foremen, engineer, and project managers retain key experience on their heads, and yes, they can apply those lessons learned on future projects, but there's no way for the construction businesses to capture this knowledge. In more mature industries like the airline industry, they actually have standard operating procedures, process logs, and even automated sensors for capturing and retaining this critical tacit knowledge. The next reason data capture is challenging on construction project is that nuances often aren't captured. Important context around data we may track will often be missed, such as weather delays, design issues, site workarounds, and staging may never get recorded and associated with things like production rates or activity durations. Reason number 6 is the high pressure, low time problem. All construction projects are busy and stressful and often under-resourced, and everyone prioritizes progress over documentation. In industries like manufacturing, they'll actually schedule downtime and QA processes as part of standard operations. They'll actually schedule as part of people's routine work, data capture, and build it into processes when construction is just all about speed and progress. The next reason is fragmented tooling. Construction projects use a lot of different tools for specific different tasks. You might do estimating in Excel, scheduling in P6, site notes in a WhatsApp chat, photos in our phones, and nothing ends up integrating. So we miss a lot of context and nuance about the data we're collecting because it's recorded or stored in so many different platforms. The next one, which is a huge one I see on projects, is there's just no incentive for the project teams to track and record data. Project teams are always measured on the success of the project, whether the project makes money, whether the project finishes on time, when there's no safety and quality incentives. The team just has no incentive to actually set up, track, and record data in any sort of meaningful way. The next issue is that the construction sector has poor data governance. There's not standard rules of measuring, how to break down tasks, standard activity lists between projects, folder structures, field definitions, or frequency with which we record. It's just not good data structures that everybody follows. Another challenge with collecting data in the construction industry, and this is particularly a big difference to things like manufacturing and e-commerce, which are automated software using robotics, is that construction is all about complex human workflows. There aren't sensors we can measure. We need to get people to manually record data and ask about tasks. So again, manufacturing, we might have some robotics involved. There'll be sensors that track when something goes on the production line and when something comes off, and we'll get a time. If we want to record how long it takes an electrician to terminate a cable, we need to ask the electrician. We need to get him to record the times. All of construction is complex human workflows, which is just inherently much harder to track properly. Similar to the poor incentive to record challenge is that projects inherently just have a one-off mindset. People want to finish the project, do the project well. They're treated as isolated jobs and they're not thought of as part of this bigger ecosystem as the construction business. And because all this data is so difficult to track, so difficult to use, is that we often don't even try to build feedback loops. We don't even try to set up systems where we use our cost tracking to improve our estimating or our lessons learned to improve our next project. It becomes something too challenging to do, so nobody even tries to set up proper systems for doing so. The problem with construction data isn't that it gets lost or that there's not enough of it. It's that the whole system is not designed for data reuse. I want to go into a little bit more detail on a point I made earlier, which is that data matters even more now, and our reliance on data is only going to get increasingly important. Artificial intelligence is coming, it's here, and it already has some incredibly powerful applications for the construction sector, but these AI tools are built on data and context, and the only way to get the most out of our AI systems is to properly manage and be able to use our data. First reason why this is so incredibly important is to be able to use these large language models like ChatGPT or Claude effectively. They need context. These models become more powerful and more applicable only when they're fed relevant information about the problems we're trying to solve them. If we give them generic, useless information, we'll get generic, useless answers. If we give them specific, actionable information about the specific problem we want them to help us solve or the task we want them to do, we'll get much better information. If we want Claude to produce a delay notice, we need to give the relevant supporting information in context. The limit of these tools is the context and information we can provide them. The next reason that data is increasingly more important is that these AI models thrive on patterns and recognizing patterns. If our data is structured, it allows AI to analyze trends, detect anomalies, and automate repetitive reasoning and processes. The next one, which I think is a critically important insight for the construction industry, is that unstructured free text data, which a lot of our data has gone from not really being very useful, requiring a huge amount of manual processing and categorizing, to now being very accessible and very usable. AI can now make sense of the huge amount of text data that we used to ignore. For example, say across the years we collected thousands and thousands of defect logs. They might have all had slightly different descriptions. One spoke about concrete cracking, one spoke about poor curing of the concrete, one spoke about the wrong mix design. In the past, this would have just lived like a huge text file or a huge set of rows in an Excel document. We can now give that to AI, get it to process it, get it to analyze it, tell us what the key defects are, what the key mistakes that we're making. All this unstructured free text data is now usable. The final reason why AI is making it more important for construction companies to manage their data is that contextual data, or data we have about specific events, what's happened, site diaries, records, allow us to develop smart automations. When in the past we used things like software, filled out a site diary, and logged that site diary in a database, now we can take all the site diaries in our database and we can develop smart automations, things like generating progress reports, updating our cost tracking, all these tasks that used to require people manually going through and doing them. Using these large language models and AI tools, we can automate the entire task. Basically, the data divide is growing. Companies that can structure, track, and manage their data better are going to get better results from these tools. Construction has always relied on data. That data, most of the time, came from people's tacit knowledge and lived experiences, what they remember happening on a project, what they understood about the specific task for planning, monitoring, and tracking and monitoring records. Now with AI, that data is becoming much more powerful and we're able to do many more things with it. Structured, consistent, and accessible data isn't just helpful anymore, it's a competitive advantage. It allows us to do new types of automations, improves decisions making, and lets AI generate new documents and new insights. Okay, so to understand why managing data on construction projects is hard, why data matters, and why it's going to increasingly matter even more in the future, let's now talk about what good construction data management looks like. At the end of the day, it's all about understanding how we can use data to improve projects and business performance going forward. First thing that makes our data usable is if it's structured. What does structured data mean? It basically means we're using tables, codes, drop-down menus instead of simple free text field. Say, for example, our construction site diary is a report that someone fills out every day and it ends up just being a huge set of free text data. Doesn't end up being that useful. We can't filter it, it's harder to analyze, and it's harder to compare. But if we have structured input with tables, codes, different cost codes, quantities that we can compare against project and dates, it becomes much more useful. The second thing that makes our data much more useful is if it's centralized. What does this mean? It means we're using one platform or one system to capture all our data. Think about it like Airtable, Notion, Procore for our entire businesses. All our projects are using the same tool to capture data. This prevents data being lost across different documents, WhatsApp chats, and email, and effectively just makes it much more easy to access and use. For example, keeping all our subcontractor RFIs and approvals in one shared project folder. The next thing, and this more or less goes without saying, but ensuring our data is relevant. What does this mean? It means capturing the information that actually matters. What information matters? It's things that's going to help us improve our project performance and business going forward. So these are things like productivities, causes of delays, whether we can use to justify claims, amount of rework, and what the cause of that rework is. This is information that we actually need to make better decisions, to prove contract claims and these sorts of things. It's much more valuable than just recording a whole lot of noise that maybe we have a hope that one day it'll be useful. But at the end of the day, it's much better to track things that you know actually matter. And then the final thing to enhance our data and make it more useful is to be consistent. To be consistent across projects, across team members, that we're all using the same naming conventions, records, work breakdown structure, cost codes. If we standardize all these things, again, we're going to be able to compare data across team members, across projects, across activities. It's going to be much more useful. Okay, next let's talk about the key types of construction data. We're going to go through what the data is and what are some key data types that we should be tracking. Perfect world for construction business, this is the type of data they would be tracking on all their projects in a structured, centralized, relevant, and consistent way. So what type of data do we care about for construction companies? Well, first is cost and financial data. This is more than just your bucket. Good financial data breaks down how money flows, where it gets lost, and how it performs against the plan. In the perfect world, we'd have some sort of feedback loop where we're tracking our cost data on our project and we're using it to improve our estimates going forward. As I previously spoke about with that example of the inverter earth grids, it's a surprisingly challenging thing to do on construction projects. But what should we be tracking? The key data we should be tracking or capturing is our budgeted cost. So these are our breakdowns of the project budget by trade. These are our estimated cost, our forecast cost. So these are revised expected cost to complete as we're progressing through the project. Our actual costs, which is the actual amount of expenditure in invoices, payrolls, supply bills against each of these cost codes. Our committed costs, so our purchase orders, subcontractor agreements, these are costs we've committed on the project that we have not yet incurred. Our variation cost, what we're paying in variations to our subcontractors, what we're claiming in variations to our client. Then our productivity rates, which is where we compare cost and output per unit. We'll talk about this a bit more when we talk about scheduling data. And unit rates for different activities. So this might go above the cost code level, where instead of looking at simply a rate for formwork or concrete placement, we're combining this into a unit rate for benchmarking the total cost of supplying and installing concrete structures, which is going to be useful for checking our estimates. Now, this type of data is all about the money and capturing the costs of doing the work. Okay, the next data format we've got is going to be our change and contractual data. This is all going to be about substantiating variations, getting variations approved, disputing variations with our subcontractors. It's all about avoiding he said, she said situations. So for example, we've got variations requests, the reason, the amount, the status, whether it's approved or not, delay notices, when they were submitted, how many days, what activities they were linked to, what data do we get from both our schedule and our cost data can we use to substantiate these, client instructions, our subcontractor claims to us, and RFI logs. And the final type of data we've got is our daily site intelligence. So this is basically just tracking key metrics, notes, observations people are making on site. It can be used to help track labor, which will support our schedule and cost data, but also necessary for doing things like timesheets and paying people, material deliveries, what time they came in, who the supplier was, the quantity, which would be used to reconcile subcontractor invoices. So this is just basically logs of everything that's happening on site. Again, I want to wrap up this section by talking about something that I think is critically important but often overlooked. The biggest challenge you'll have when recording or tracking all this data isn't necessarily recording it, but it's using it later because the data doesn't speak to each other. We mentioned how our cost data, our schedule data, our quality data are all fundamentally related. How long the project takes to do impacts how much it costs. The amount of defects we have impacts how much it costs, how long the project takes. We need a way of integrating all of this data together to get the most out of it. And the only way we can do that is to have a unified framework where all our projects are tracking the same information in the same structure. And this comes down to 4 key parts. Having a unified task structure, so a unified way of tracking all the different tasks on the project, using the same metrics across projects to track these. So if we had a task for formwork, we track on all our projects, we use the same unit of measure, which is man hours per meter squared to form and strip, or whatever we choose to have. Tracking our external factors, so what influenced the outcomes of the project, and tracking what decisions were made. So the most important part of this is our tasks, having a structured way across all our projects of categorizing different tasks. This matters because it gives us a common reference point to join our schedule, our cost, our quality assurance, and any other data. So for example, if we have a task of formwork across all our projects, we're always going to know what it costs per meter squared to supply and install formwork on a project, how long it took, what quality issues we had. It's all tracked at the task level. It gives us the ability to make historical comparisons across projects or across tasks and projects, and it supports AI analysis. We could ask questions like what usually goes wrong with this task and integrate it into our checklist going forward. The way we do this is through the most powerful project management tool, which is the work breakdown structure, and a unified, consistent work breakdown structure that we use the exact same thing across all our projects. Once we've got a unified work breakdown structure, the next thing we need to have a unified metrics. We use the same metrics on all our projects. For each task, we collect performance data in the same way. This means we're tracking Our costs, so our actual versus budgeted, our unit rates, our committed versus forecast costs. We're using the same metrics to calculate our schedule, our durations, our percentage complete, our planned versus finish date variance, our productivity, our crew hours per unit. We're using the same units across all our tasks. We always measure formwork in meters squared, formed and stripped. We always measure earthworks per meter cubed. Our quality, the way we're tracking and categorizing defects, and our safety. Again, this is going to allow for real-time control and project-related decisions. They're going to be much better, much easier for people to get across quickly because they're tracked the same way on every project. People can understand a project very quickly by looking at key metrics, but for people to develop that sort of intuition, you need the same metrics used across projects, calculated the same way. People can quickly spot the differences. And again, it's going to support forecasting, benchmarking, and using that information again. The next part of our unified framework for managing data on projects is tracking external factors. Now, again, in my experience, this isn't something that's often tracked in a reliable way, but not all delay costs, not all poor productivity is from incorrect estimates or poor planning. Many are due to external factors like weather, whether we've had a lot of rain, high wind, extreme heat, issues with site access and deliveries, delays to the design or extensive RFIs and rework, client actions such as delays from the client or instructions from the client, or permits and regulatory holdups. Tracking these external factors and how they impact these other core tasks and the metrics we're tracking is going to help us to understand our data better, enable better future risk assessments. And again, because we've got this power of understanding our data better with AI, because we've got access to all our free text data now, it's going to be able to, again, capture lessons learned from projects if we're tracking our external factors and giving this more concrete task and metrics. We're tracking better explanation power. The next type of data we should be tracking is schedule and progress data. So scheduled data is all about the activities we're doing, how long they take, what resources we're allocating to them, how much work we're getting done per unit of time, per crew member. And we can combine this with our cost data. When we talk about schedule, progress, and cost data, we're really talking about the function of project controls. So what type of data should we be tracking? For specific tasks, our planned versus actual duration, how long did we think it was going to take? How long did it actually take? Our progress percentage update, so tracking for every task in our project, where it's at, how much we need, how much work we have left. We can calculate our production tracking, so breaking tasks into meters squared per day, meter cubed per hour, day, whatever the relevant unit is. Delay logs, so where we're getting delayed, what the cause of that delay is, sources of variance, where we're wrong about our forecast, why we're wrong about our forecast, activity linkages, what are the order tasks need to be captured. Now, we don't often capture this sort of thing, but one of the biggest sources of delay in a project isn't necessarily anything happening that was unplanned, but it's just we didn't properly capture linkages. We missed linkages. This leads into the next point of capturing our look-ahead data, how accurate we are with our short-term forecasts. The next category of data we've got is our quality and safety data. So this is really capturing both compliance, risks, hazards, observations. So what type of data can we be tracking? Our inspection and test plans and how the tasks were completed, what inspections we had, what issues we had, non-conformance reports, categorizing them by type, what the cause was, the design specifications or mismatch, severity, the resolution, our defect logs, what are all the different types of defects we're having, what's the cause, who's responsible, rework data, SWIMS compliance, and recurring issues. All this data, again, should be tracked carefully, but this is going to end up being a lot more free text data that, with the power of large language models, we've actually now got some very useful applications for. Now, the final part of our unified framework for managing our data is actually tracking the decisions we made and why we chose to do certain things. Again, it's going to give the previous data we've spoken about better context, and it's going to help us actually assess whether we're making the right decisions, because the only way we can work out whether we're making the right decisions is to track them, assess whether we're making the right calls, and then improve these decisions going forward. tracking things like, why did we change the crew size? Why did we approve that variation now instead of later? Or why did we push that pour back 3 days? This is all important context for us to help understand our data. It helps us to reconstruct logic, assess whether we've made the right decision, capture lessons learned. And again, AI tools and being able to understand that free text data in our construction data is going to be incredibly helpful with improving our decision making going forward. Okay, so we understand we need to track cost data, schedule data, quality and safety data, and our daily site intelligence, and that an integrated data framework is ultimately what is going to allow us to get the most out of our data. It's going to give us better forecasting, better root cause analysis. It's going to give us the ability to do cross-project benchmarking, provide stronger claims and support our variations, and give us the ability to extract AI-driven insights. Okay, so we've spoken about construction data in a lot of detail and given you some frameworks for how to think about managing data on a project. I want to quickly wrap up by giving you a 5-step process you can use to approach managing data on a construction project. Okay, so here's a practical approach to managing data. Number 1 is start with a purpose. Before you capture anything, ask, what are you actually going to use this data for? You're going to use it for monitoring, controlling, generating AI insights, record keeping for legal protection, or for future reporting and forecasting. The purpose you're using the data for will eventually shape how you choose to capture it and structure it. If it's for legal protection, you want timestamped photos and site instructions that are signed by your client. If it's for forecasting, it will focus on consistent task level productivities. So once you've decided what you're going to eventually need the data for, the second step is to choose what to capture. So you can't track everything, so focus on the high leverage data points. Cost data, for productivity data, changes to scope, risk, and key constraints, and compliance or quality assurance data. Again, it's about asking yourself the question when you're specifically choosing what to capture is, will this data help us improve this project or the next one? If you can't succinctly answer that question, then it's probably not worth wasting the time and effort to capture the data. The next step is to decide how to capture it. This is the biggest challenge you see, because if the data is difficult to capture, it involves people filling out long site diaries that take hours or doing lots of extra work. At the end of the day, it's probably not going to be captured properly. So you need to choose a way to capture it that is very easy to do, or perfectly, you could automate it. So it's not easy to capture, it won't get done. You should prioritize tools and workflows that fit into people's daily routines, or they can do with the minimal amount of effort possible, such as forms and templates that automatically get sent to people that they can fill out on their phones, photos and voice notes, or automated sources such as a weather feed, GPS tracking, time card apps. You just have to think about this carefully of how people are actually going to capture the data. Because say, for example, a foreman isn't going to bring their laptop with them to a concrete pour. So if you have a digital checklist, they need to be able to access it on their phone. So once you've worked out how you're going to capture the data in the easiest way possible, the next thing you need to do is choose where to store it. Again, you want a centralized database of all your project data. Your data needs to live somewhere that's searchable, where you can quickly find diary notes or variations through keywords or dates, structured with folders, tags, task IDs, and clean formatting that's easy to understand and for people to refer to, but also secure and accessible. Some popular options: 90% of construction companies will do all of this in Excel, and I've intentionally not put this on there, but Airtable, I've been loving and playing a lot with recently. I think is incredibly good at this. Notion and Procore, I know they have this functionality. I haven't played with it much. I know Procore is construction specific, but it's very expensive. And then if you want, you can use SharePoint and Excel documents. I find the cloud function on SharePoint almost always causes headaches with people overwriting files, and I have no idea why it's so bad. But every project I've worked on, we've had huge issues with people overwriting data in SharePoint. Some people working online, some people working offline, and it always causes headaches. The final thing is to design it for use later. I am probably overdoing this point because I spoke about it starting with the purpose and choosing what to capture, but don't just collect data, design it so it's useful when you need it. Again, if you're tracking cost data, why are you tracking cost data? You're using it to forecast and control your project, or do you want to track it so you can use it for your estimates going forward? You need to talk to the people who are actually going to be using the data. So if you're tracking it to use on future project estimates, talk to the estimators, what structure they wanted it. Again, all comes down to designing how you're capturing the data so it's usable for later. Using drop-downs in codes instead of free text, timestamping, attachments, and authors if it's contractual data, linking the data to tasks and areas, having a standardized task list across projects, and ensuring naming conventions and templates are followed. Again, the question you should be asking, if I come back to this data in 6 months later, will it still make sense? At the end of the day, everybody in the construction industry loves to talk about how data is the future, but if you can't find a way to use it and you can't set up your systems to capture it properly, design it for the people who are actually going to use it, it's just going to end up being a big waste of time. So hopefully this video gave you some useful tips for how to manage your construction data more effectively.